Hello friends, welcome back once again in the video lecture series of system programming. As I have already discussed some facts about compiler and interpreters, and in that I have also explained different phases of compiler. Basically there are 6 to 7 phases as I have already taught you, right? Today I am going to take one of the important phase, that is known as code optimization. Why I have taken this code optimization as a separate phase? Because 40% of compiler activity, whatever the compiler is performing the task, 40% of its task is consumed by code optimization. Really, if you will believe it or not, when you will study compiler design separately, and in that when you will go to study this code optimization in deep, then you will come to understand this point that in ADA, whatever we have learned, that was not sufficient. So for example, suppose I am having a problem P, right? And suppose there are 3 algorithms A1, A2 and A3. There are 3 algorithms are there to solve this problem. Now anybody will ask which of them is better. So you will opt that algorithm which is having the time complexity very less. That means out of these best algorithm, you will choose that algorithm which is having less time complexity. Suppose I have chosen A2 as the best one. Now the question is our computation problem has solved? No, not at all. Why not? Because selection of an algorithm and implement it in any programming language is not at all sufficient. Why? Because when you are going to implement the algorithm in any programming language, when it is written in some code and when it is analyzed by a compiler, then we are in the real stand that our algorithm or our program execution is efficient or not. To efficiency of a program means we should have the higher computation value. That means the efficiency of program must take less time. But taking the less time is not at all only depend upon the algorithm selected according to the time complexity. No. Code optimization is playing an important role in that. Let's see how. So, to begin this code optimization, first of all, we should understand the meaning of code optimization. Code optimization means optimization of code. Suppose we are having so many codes. Now, out of so many codes, can we analyze that some codes are redundant? And if some codes are redundant, then the redundancy of that code should be eliminated to improve the efficiency of a program. That means code optimization is strictly aims on efficiency of program by, first of all, removing the redundancy of a program. Whatever the redundancy codes are there, we will try to eliminate it, right? First thing. Second thing is that computation of a program is rewritten. Say for example, I am just taking one example. Suppose I am having one instruction, that is x is equals to a plus b into c. Okay, after that, after some coding, what we are getting, y is equals to, say, let's take let's take d minus b into c plus say p, like that. Next, suppose z is equals to let's take y minus b into c plus q minus b into c divided by c plus d, or just take it as m plus n. So what is the significance of computation of a program is to be rewritten. Here we have seen something that see b into c here, b into c here, b into c here, b into c here. That means we have to perform b into c at least 4 times in the entire program. So why don't we not do a small computation to store the value of b into c in a temporary variable for certain time, and instead of so many calculations, this may be rewritten as, let's take temporary variable is equals to b into c, right? And this code will be written as x is equals to a plus t. This will be rewritten as y is equals to d minus t plus p, right? And for z we can write it, that is z is equals to y minus t plus q, this is q minus t divided by m plus n. So here what we have done, in these two codes, both codes are same, but in the first statement what we have done, every time we have calculated b into c, but in the second code I have calculated only once, that is t is equal, let's t is any variable, not a temporary variable, let's take any variable, and I have stored the multiplication of b and c in t, and wherever b into c is being called, I will just put t. So this is the best example of what? Code optimization, where we have optimized the code. We have optimized the code like, so instead of doing 4 calculations, I will just take one calculation for b into c, and rest I will just put the value. This is only a basic point of code optimization. However, there are so many different examples of making code optimization so simple, so easy, and so efficient for program execution. So as our this lecture will goes on, I will take the code optimization into different section, and there I will explain with the help of different codes that how really code optimization is done. Here, whatever I have given you, the basic concept of the programming was one example only. Instead of so many calculations, same calculation, why should I make the same calculation once again and again and again? So instead of that I can store the multiplication of b into c in t, and I will substitute the value, right? Okay. So what does compiler do for code optimization? See, for code optimization, compiler analyzes the program, and on the basis of analysis of program, it collects the valuable information which is related to that analysis. Okay. As I have already told you, what is the basic reason to make this video for you separately for code optimization, because 40% of code optimization, 40% of compiler task is depend upon your code optimization only. Okay, if I am going to extend my views on code optimization, then first of all I am having optimization transformation. See, what do you mean by transformation? Transformation means, suppose a program is given to you, and if you want to rewrite the program without the changing of its meaning, see, this is the one code, this is the separate code, right? But the thing is that दोनों को अगर देखते हैं तो इसमें आपकी मीनिंग बिल्कुल चेंज नहीं होती, ये वही मीनिंग है जो ये मीनिंग कह रहा है, बट यू कैन सी कि दिस कोड इज नॉट ऑप्टिमाइज्ड बट दिस कोड इज ऑप्टिमाइज्ड. हाउ? एक्चुअली ये कोड हमारा ट्रांसफॉर्म हुआ है किसी दूसरे तरीके से, राइट? So the main thing is that कि rewriting of statement without changing the meaning of the program statement, हमें प्रोग्राम के स्टेटमेंट को रीराइट करना है, बिल्कुल करना है, लेकिन उसका मीनिंग चेंज नहीं होना चाहिए, राइट? ओके, सो optimizing transformation is of two types. One is your local transformation, second one is your global transformation. When the transformation is depending upon small segment of program, then it is known as local transformation. And when the transformation is depending upon overall or large segment of program, like looping, then it is known as looping, or function, then it is known as global transformation.